Hello friends, welcome back to our YouTube channel. In this video, I would be explaining you how you can analyze and design a RCC column in Staad Pro. So friends, let's start generating a simple frame or portal which will be consisting of two RCC column and RCC beam. So friends, let's click on new project, then space, selecting our unit system, add beams, and we will end up on our main window. I'll be changing my default grid from XY plane to XZ plane. Now I would be creating one node here and other node here. So I will be doing Control C, Control V. This is the another method with which we can copy the nodes. I can just use node beam method also, uh, which you can refer from my earlier videos. So in this video I will be covering how to make nodes, uh, how to make another node from one node. Okay, so let's suppose I want a node in X direction. So I would be at a distance of 5 meters. So I would be copying that node to 5. Okay, so I will get a node here. I'll do this one. Shift. I'll make our nodes visible. Shift K. So these are the two nodes. These are the two nodes. Now what I will do, I can use our command translation repeat for generating our nodes above, but I would be using this Control C and Control V. There are many methods which we can use for creating a model. So Control C and Control V, and in Y direction, let's assume at 5 meter, sorry. So now we get four nodes. Okay, now I would be connecting these nodes. I use my add beam cursor. So this add beam is for connection between two nodes, right? I will be adding beam like this. So this is another method by which I can generate my model by using Control C and Control V. Okay, uh, so now our model is complete. Now let's assign some property to this one. I'll be assigning, let's assign a rectangular, let's assign a rectangular column of size 400 by 400 mm, and I'll be selecting concrete as my material since it is RCC. So I'll be adding it and I will be assigning it. Now what I will do, I will be this since this horizontal member is a beam, so I would be assigning one property of a beam. So let's assume 0.5, YD is 0.5 and ZD is 0.3. Taking material as concrete, I'll add it. Similarly, I will assign it. Okay, now this is our model. This is a model which we have made. So let us see a 3D view of it. This is a model. Okay, this is a rendered view. We can also use Control 1 if we want to have some extrude view of it. Right, Control 1, Control 2, and Control 0 for removing it. Right. So friends, now we have assigned a property to our model. Now what we will do, we will be using supports. I will create fixed support and I will assign these supports to them. We have assigned our supports. Now what we will do, we will be assigning some loads over it. I'll assign some load over it. So dead load, add. Now in dead load I will be adding what? First sulfate. Okay. Now another I would be adding some nodal load, let's say nodal load of minus 10 kilonewton I have added to it. That one. You when you are working on your current project or when you are working on your live project, you need to save that one, otherwise there may be chances that this project you're working may be lost. So you need to repeatedly save your work. Okay. Add one more load I want to assign. Suppose over the beam I want to assign a member load of UDL. I want to assign a UDL of, let's say, 5 kilonewton per meter over it. I will add it. Now I will assign it. So as our self weight will be on a whole structure, right? And after this is question mark here. Since I didn't assign my loads, so I'm getting this type of icon here with question mark. After assigning, I get this type of icon. I will add a point load over here. See, it is again quite high. Let me reduce this one to 5. Okay. Now I'll assign my another load. I'll assign it over a beam. So this is my UTL. I can also scale my this load UDL. I can scale it from here. Okay. Suppose point force I want to make it little big. I want to make it look a little bigger. So I would be doing like this. Okay. If you want to view the load whatever you have applied on your model, you can view it like this. You have to add shift V. Okay, this is our UDL. It is minus 5 kilonewton meter, and this is our point load, which is 5 kilonewton. So if I want to view one load at a time, then I have to use this. I have to go to this menu, change display unit. Then I will go to assign drawing. I'll be using this only show label for selected item in the dialog box. Okay. Now whatever load I will select it, that only will be reflected here. But it is assigned to our structure. But if you want to select only one load and view only one load, then we can use this command. So 5 kilonewton meter per meter are uniformly distributed load. So guys, we have assigned our loads to a simple portal or frame. Now what we will do, we will assign perform analysis, we will add perform analysis here. Now we will run it. So our model has run. So go to post processing. Let's see first. So I'll show you the deflection diagram of our model. I'm scrolling my mouse. I can see here. We can view the value of deflection here by using result, u value, displacement. Okay. Now let me show you the bending moment diagram, my bending moment diagram and my shear force diagram. Okay. So this is my bending moment diagram. This is my shear force diagram. If I want to uh, see the values here, then I can always go to my result and see the view value from here, right? Now what I would want to do, I want to also see the value of my moments and all in this table, right? So I'll select beam 1. So this is my beam 1. If I use shift B, then it will indicate, it will show my beams. Okay, it is hidden here. You can, if you can see, this is 1, this is 2, and this is 3. Okay, I can also make it, we can also shift this 2 here, shift this one here. We can do it from here if you want to do center, right, and left, and all that one. Beam labels, you can select it from here. Okay, if I select horizontal alignment as left, it will come to left. Okay, from center it has come to left. So this is my moment mz, and this is my axial force, this is my shear force, right? It is also giving me some axial force. Let us see how much is that. This is our axial force that is coming. Okay guys, now what I will do, so this is the force we are getting after analysis of a frame, right? You can you can extract the forces from here and manually design this with the help of your Excel sheets or spreadsheets that you have made for column design. You can extract from here report for there are many, there are various. If you want to select the beam forces, I will select my beam, then I can extract my beam forces from here, right? Loading, it will give me a table, and there are other reports also, joint displacement, support reaction, whatever reaction you are getting and all that one. If we want to see your reaction, what it is here, then we can always see from here reaction. Note, this is a displacement, we can see displacement for him from here. This is reaction. Similarly, beam is there, forces is there, from where you will be getting your forces of bending moment and shear force with torsion and axial force, right? This is our stress graph, whatever stresses are coming on our beams and columns, right? Now since this video is over design of column, let me do the design of column. Okay, so I'll go to design, then concrete. I'll be selecting my code as IS456, and I will be defining parameters. So clear cover, let assume that clear cover is 0.04 40 mm. I'll add it. Then FC, grade of concrete as M30, right? So I will be putting 30,000 in kilonewton per meter square. Okay. Add FY as 500, adding it. We can use this one, or Staad will automatically select the reinforcement and it will show you in the design of column or design of beam. So you can select it. Also, if you want that you only want like 16 mm dia reinforcement, you can select it here. So this one is your ratio, uh, whatever maximum ratio you want to, maximum ratio of maximum longitudinal reinforcement you want to provide. You can put your value here. Now what I will select is track. I want a complete track, so I'll adding it. Now I would go to command and design command. This design of beam is for beam. This design of design of column is for column. I will add it, and again take off for my uh, concrete and steel what is coming. Okay, now I will assign it. Since our column is having clear cover of 40 mm, I will be assigning this to my column only. Let assume that our beam is having a clear cover of 30 mm. So I will be putting 30 here, 0.3 here, and I would be assigning my beam. Okay, grade of concrete is for let's assume that it is on over whole view. Okay, similarly this is over whole view, track view and everything for beams and column. Full design, this is for column only, since we are designing the column. If I want to design the beam, then I would be adding from here, I would be adding design beam also. So I will run it now. I've defined all the parameters, required parameters. So now I'll see the output file. This is my column design, right? This is my column design. Maximum PU, maximum MU, maximum MY, then governing worst load case, since we have only assumed one load case, so it is that one only. Right, now let me double click it. I'll double click it, and this is my column design. Right, it is giving me reinforcement, and what is the governing, how much AST percentage it is providing. AST required also it is providing, and bar, how much bar you required, it is also giving me like this. Similarly this one, if our columns get failed, right, then this concrete design will not be reflected if you do double click, if our columns are failed, right. You can also check from here. If our columns get failed, you can also check from here. It will say that your column is not adequate, it is failing in something and something like that. So you can do the column design like this. So guys, if you do like my videos, please like, share and subscribe. Also hit the bell icon for the latest videos. Thank you and goodbye.